Let's study the next term called as linear magnification. In the ray diagram, we studied the image formation of an object kept in front of a convex lens or a concave lens, and the image formed due to refraction of light through the lenses was sometimes real because it was formed due to actual intersection of the rays, and sometimes the image was virtual because it was not formed due to the actual intersection of the rays. But if I talk about the height of the image, sometimes the height of the image was greater than the height of the object. Such image was magnified image. Sometimes the height of the image was same size as that of the object, and sometimes the height of the image was smaller than the height of the object. So such image was a diminished image. That means the image formed, right, whether real or virtual, was magnified, same size or diminished, right? So if I compare the height of the image to the height of the object, okay, I get a term called as linear magnification. So in short, linear magnification is defined as ratio of height of image to the height of object. So linear magnification is defined as a ratio of height of image to the height of object, and it is denoted by letter small m. So I have written small m, which is linear magnification, as the ratio of height of image to the height of object. So small m can be written as hi by ho. This linear magnification is also called as lateral magnification or transverse magnification. It is also called as lateral magnification or transverse magnification, but now we will only call it as a linear magnification. It is also, this ratio is theoretically also equal to image distance, right, upon object distance. Remember, theoretically it is equal to the ratio of image distance to the object distance. So linear magnification m can be written as hi by ho, or it can also be written as v by u, and no proof is required whether how it is equal to v by u. It is theoretically proved, and all these proofs are there in your textbook, right? And no proof is required. You just need to say that linear magnification is hi by ho, which is also equal to v by u. So we have a formula for linear magnification. And remember, since linear magnification is a ratio of two height or two distances, it has no unit. So I will say m, linear magnification, has no unit. It is a pure number. But the proof of this might be given in your textbook, but again I will say no proof is required. Simply linear magnification is ratio of height of image to height of object, or it is a ratio of image distance to the object distance. Now the value of linear magnification will help us to calculate, right, the nature of the image, how to get the nature of the image using the value of linear magnification. But remember, whenever you are substituting the values of all these terms hi, ho, v or u, you have to use sign convention. So whenever you are calculating linear magnification, the sign convention is very important. So whenever you calculate m, you have to use your sign convention for the given values of v, u, or maybe hi by ho. Now using the sign convention, the magnification can be positive or negative, and the value of the magnification can be greater or less than 1. So remember, if I tell you the step to find the nature of image, steps to find nature of image from linear magnification. So there are two steps. If I say step 1, you have to say check sign of m. Okay, whether the magnification is positive or negative. And if M is positive, if magnification is positive, then image is virtual and erect. Definitely virtual image is always erect. And if magnification is negative, so you have to say image is real and inverted. So by checking the sign for the magnification, you can easily say whether the image is real or virtual. So if sign of M is positive, you have to say image is virtual and erect, and if sign of M is negative, you have to say image is real and inverted. I will talk about step 2 now. Step 2 says that check value of M. Check value of M, that is mod M. Whenever I talk about mod of a number, let's say mod phi का value is phi and mod minus phi का value is also phi. So whenever a mod is there for a given number, that number will always be positive. So I am telling you to check the nature of image, you have to check the value of M, that is mod M. I will say without sign, just check the number, and if that mod M ka value is greater than 1, if mod M ka value is greater than 1, so you have to say image is magnified. Image is magnified. If mod M ka value is equal to 1, you have to say image is of same size. Image is of same size. And if mod M ka value is less than 1, so you have to say image is diminished. Image is diminished. So you have to check these two steps to find the nature of image. The first step, remember, check the sign. If the sign is positive, then image is virtual and erect, and if the sign is negative, then image is real and inverted. If the value of M, that is mod M, is greater than 1, then it is magnified, equal to 1, same size, less than 1, diminished. I will give you some example which will help you to calculate the nature of image, and you can also name the lenses used, right? So it will take 2 minutes. Let's talk about magnification. Magnification, then I'll talk about nature. Okay. Then I'll also talk about type of lens. One thing you have to remember, convex lens can form real as well as virtual image, but concave lens can only form virtual image. So if I say magnification, let's say I can take it -3. Okay. So magnification is -3. Using this value, I have to find the nature. So what is the first step? Come on, tell me. You need to check the sign. So if magnification is negative, okay, what did we learn? That if magnification is negative, then the image is real and inverted, right? So what is the value of mod M? If I say mod M, it will be 3, which is more than 1. So real, inverted and magnified. Real image is only formed by convex lens, you can say, right? If I say magnification is -1/2, magnification is -1/2, again, since magnification is negative, then it is real inverted. And if I say mod M, it will be half, which is less than 1, so diminished, right? So image is real, inverted and diminished, okay? And since image is real, the lens will be convex. And if I say magnification as -1, minus again real, inverted, and if it is 1, 1 is a means same size, real, inverted, same size, since it is a real image, still it will be formed by convex lens. And if I say magnification is +1/3, let's say +1/3. So plus, magnification is plus, means image is virtual and erect. And what is mod M over here? 1/3. So it is less than 1. 1 by 3 is less than 1. So it is definitely diminished. Virtual erect diminished image, right? Virtual diminished image was formed by concave lens. And if I say magnification is plus 2, plus means virtual erect, 2 greater than 1, so it is magnified. Definitely it's a convex lens. Remember, some students think that magnification is minus 3, so it is less than 1. No, if you are comparing it with 1, only use the mod MK value, that means only the magnitude. And when I say magnification is minus 1, this is a case where object is kept at 2f, image is obtained at 2f.